Okay, so good morning class. So our lesson for today is about the compass rule, no? Or how to adjust, okay, yung given traverse by balancing the latitude and departures. So balancing the latitude and departure for a traverse attempts to obtain a more probable values for the locations accordance of the traverse, no? So popular method for balancing errors is called the compass or the Bowditch rule. Now, the Bowditch rule, as Nathaniel by this person, okay, Nathaniel Bowditch, a surveyor, navigator, and mathematician, as a proposed solution to the problem of compass reverse adjustment, which was posted in the American journal The Analyst in 1807. So the compass method assumes the following. First, angles and distances have the same error, and second, errors here are accidental. So the rule states the error in latitude or departure of a line is to the total error of the latitude or departure as the length of the line is the perimeter of the traverse. So from this statement, we can generalize that a as an equation. So as in this form, no? So yung error natin is small e for the latitude or departure. Um, over the total error. So yung total error is big E L over T as the length of the line. So let's say the given line segment is line AB over the perimeter. Okay. So we're after to this variable. So we try to isolate this to give us a formula in order to quantify the error for the latitude and departure as the E sub LD times LAB over the perimeter. Okay. So if we try to consider this example, so we're given here a line segment AB to EA. Okay, and for each line segment, we're given here the direction or the bearing as well as the length. No, so we can tabulate our values. So recall the results. Okay, from our previous example. So for the side AB to EA, we're given the bearing, the length. We compute for the latitude and departure as well as the perimeter. Uh, Total error, or this is a summation of total error in the latitude and yung error in the departure. So our aim here is to make it zero. So to make it zero, since it's negative, we need to add, okay, yung error for each line segments for the departure and latitude. So if we try to consider, again, the first line segment, AB, given the direction or the bearing and the length, we compute for the latitude. So this turns out to be negative 188.40. So this is negative since we're after to this component. So this is along the north-south direction. So this is going down. No? So applying the formula, so isolate the correction or error in latitude is equivalent to yung total error in the latitude. So recall natin yung table. So this is negative. So since our aim here is to make it positive, so we need to change the sign from negative to positive. So it becomes positive 0.079. No? And the length here is the length of the line segment AB, which is 189.53. So given this one over the perimeter. So perimeter here is given, or you can compute for the perimeter. So 939.46. Okay. So using your calculator, you can compute for the error or correction in latitude AB as positive 0.016. No. Next, if we try to consider the departure, okay, value of the first line segment AB. So this time we're after to this component along the east-west direction. So using sine function, so sine of the angle is equivalent to this component, departure of the line segment AB over the length. No? So the sign here is negative since from point A to point B, this is going to the left now. So negative 20.63. Then apply this formula. So the formula is error in the departure of the line segment AB is equivalent to the total error in the departure value times the length of the line segment EB over the perimeter. So again, going back to table, the sign of the total error in the departure is negative. Okay, so we need to change the sign of this from negative becomes positive so that the summation of the departure value turns out to be zero. No, so we need to add the correction for each line segment here. So positive 0.163 then times the given length over the computed perimeter. So this will give us positive 0.033. Next, try to consider the second line segment BC. So we can compute for the latitude. So this turns out to be negative 152.27. So apply this formula. So again, the total error is positive uh, 0.079 times the length over the perimeter. So this will give us positive 0.015. Then for the departure, so along the east-west direction, okay, so this time this is positive. So from B to C. So we're after to this component. So this will give us a value of 86.62. So apply again the formula. Okay. Then substitute. Okay. So this will give us positive 0.03. Okay. So we can add another column for the correction. So again, this is positive, 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 no? Okay, since in total error natin for the latitude and departure are negative values, no? Now, of course, if this is, let's say, positive value, so we expect that all of the latitude values here should be what? Negative, okay? Since our aim here is to make it zero. So doing the same process for the remaining segments, okay, you can compute the necessary correction. And of course, in order to obtain the balanced value, so to obtain this, so from the computed latitude and departure value, so we need simply add this correction so you can obtain the following values. No? So negative 188.403 plus 0.016 so give us this value. Okay, so similarly, in order to obtain this, negative 20.634 plus 0.033, this will give us negative 20.601. Okay, so doing the same process for the remaining segments, you can obtain the necessary corrections as well as the balance latitude and departure values. So as a check, we need to add the balance latitude and departure value. So the values here should be uh, exactly zero or almost zero. Okay. So we can conclude that no errors in the corrected latitude and departures. And combine the latitude departure relation with the correction give us this table. No?